From the moment humanity first gazed up at the night sky, the stars have symbolized the ultimate frontier, a realm of endless possibilities and unknown wonders. The notion of traveling to space, once relegated to the realms of science fiction and dreams, became a reality in the mid-20th century with the advent of space exploration. However, this reality came with a hefty price tag, accessible only to a handful of governments and later, a few pioneering private companies. The dream of affordable space travel, where the cosmos is within reach for more than just a privileged few, has become the next great challenge in the ongoing saga of human exploration. The journey began in earnest with the launch of Sputnik by the Soviet Union in 1957, followed closely by the United States Apollo missions, culminating in the historic moon landing in 1969. These missions, fueled by geopolitical competition and national pride, were characterized by enormous financial investments. The Apollo program alone cost approximately $25 billion in 1960s dollars, equivalent to over $150 billion today. While these missions achieved extraordinary feats, they were far from cost-effective, highlighting the immense financial barriers to space travel. The turn of the 21st century marked a new era in space exploration with the rise of private companies like SpaceX, Blue Origin, and others. These companies brought a fresh perspective, focusing on innovation and cost reduction. SpaceX, founded by Elon Musk in 2002, has been particularly influential, revolutionizing the industry with its development of reusable rockets. The Falcon 1, launched in 2008, became the first privately developed liquid-fueled rocket to reach orbit. This milestone was a significant step towards the dream of more affordable space travel. One of the key innovations driving down costs is reusability. Traditional rockets were single-use, discarded after their initial flight. SpaceX's Falcon 9, however, can return to Earth and be refurbished for future launches, drastically reducing the cost per launch. Each successful landing and reuse of the Falcon 9 has brought us closer to a sustainable model of space travel. Similarly, Blue Origin's New Shepard rocket, designed for suborbital tourism, is fully reusable, further demonstrating the potential for cost-effective space missions. Another significant trend is the miniaturization of satellite technology. CubeSats, small modular satellites, have become increasingly popular for a variety of applications, from scientific research to commercial communications. These tiny satellites, often no larger than a shoebox, can be launched in groups, sharing the cost of the launch vehicle. This not only reduces the individual cost of each satellite but also opens up space access to universities, small businesses, and developing countries. Governments and space agencies are also recognizing the value of partnering with private companies. NASA's Commercial Crew Program, which contracts private companies to transport astronauts to the International Space Station, ISS, is a prime example. By outsourcing these services, NASA can focus on its deep space exploration goals while fostering a competitive market that drives innovation and reduces costs. Crowdfunding platforms and citizen science initiatives have also begun to play a role in democratizing space access. Projects like the Lunar Mission 1 and Planetary Resources asteroid mining ventures have successfully raised funds from the public, demonstrating a widespread interest in space exploration. These initiatives not only raise money but also engage the public, fostering a global community invested in the future of space travel. The dream of affordable space travel is no longer a distant fantasy. The combination of technological advancements, innovative business models, and collaborative efforts is steadily transforming this dream into reality. However, significant challenges remain, including the need for more efficient propulsion systems, improved life support technologies, and solutions to the hazards of long-duration spaceflight. As we move forward, the continued dedication of scientists, engineers, entrepreneurs, and visionaries will be crucial. In this new era, the sky is no longer the limit. The dream of affordable space travel promises not only to expand our horizons but also to inspire a new generation of explorers, innovators, and dreamers. The journey is just beginning, and the stars are waiting. The dream of affordable space travel is gradually becoming a reality, thanks to remarkable advancements in space technology. These innovations have revolutionized the way we approach space exploration, making it more efficient, cost-effective, and accessible. The introduction of reusable rockets stands out as one of the most significant advancements in space technology. Traditionally, rockets were single-use. Once they completed their mission, they would burn up in the atmosphere or crash into the ocean. This practice was inherently wasteful and contributed to the high cost of space travel. However, the development of reusable rockets has transformed this paradigm. SpaceX, founded by Elon Musk, has been at the forefront of this revolution. The Falcon 9 rocket, designed with reusability in mind, can return to Earth after delivering its payload to space. Its first stage, which provides the initial thrust needed to escape Earth's gravity, can land back on a designated platform either on land or at sea. This innovative approach has drastically reduced the cost per launch. Each successful recovery and reuse of the Falcon 9 saves millions of dollars, making space travel more affordable. Blue Origin, founded by Jeff Bezos, has also made significant strides in reusable rocket technology. The New Shepard rocket, designed for suborbital space tourism, can carry passengers to the edge of space and return safely to Earth. Its reusable design ensures that the rocket can be flown multiple times, lowering the overall cost of each flight. This breakthrough brings us closer to the dream of space tourism becoming a reality for more people. Efficient propulsion systems are crucial for reducing the cost of space travel. Traditional chemical rockets, while powerful, are not the most efficient means of propelling spacecraft over long distances. Researchers and engineers are exploring alternative propulsion methods that promise greater efficiency and cost-effectiveness. Ion propulsion, used by NASA's Dawn spacecraft, is one such promising technology. Unlike chemical rockets that rely on explosive reactions, ion thrusters generate thrust by ionizing a propellant, usually xenon, and accelerating the ions through an electric field. This method provides a gentle but continuous thrust, making it highly efficient for long-duration missions. Ion propulsion systems require less propellant, reducing the weight and cost of the spacecraft. Another innovative propulsion technology is the solar sail. Solar sails harness the pressure of sunlight to propel a spacecraft. These sails are large, reflective surfaces that capture photons from the sun, generating a small but continuous push. The Japanese spacecraft Icaros successfully demonstrated this technology in 2010. Solar sails offer the potential for low-cost propulsion, especially for missions to distant destinations in the solar system. The miniaturization of spacecraft components has led to the development of small satellites known as CubeSats. These compact satellites, often measuring just 10 by 10 by 10 centimeters, are significantly cheaper to build and launch compared to traditional satellites. CubeSats can be deployed in large numbers, sharing a single launch vehicle, which reduces the cost per satellite. CubeSats have opened up new opportunities for educational institutions, small businesses, and developing countries to participate in space exploration. Universities can design and build their own CubeSats for scientific research, providing students with hands-on experience in space technology. Commercial enterprises can use CubeSats for various applications, including Earth observation, communication, and technology demonstration. Advances in materials science and manufacturing techniques have also played a crucial role in reducing the cost of space travel. Lightweight and durable materials, such as carbon composites and advanced alloys, are used to build spacecraft and rockets, reducing their weight and improving their performance. Additive manufacturing, commonly known as 3D printing, has revolutionized the production of space components. This technique allows for the creation of complex parts with reduced material waste and lower production costs. SpaceX, for example, uses 3D printing to manufacture rocket engine components, significantly cutting down on manufacturing time and expenses. Autonomous systems and artificial intelligence, AI, are enhancing the efficiency and safety of space missions. Autonomous spacecraft can perform complex tasks, such as docking with the International Space Station, ISS, or conducting scientific experiments, without direct human intervention. AI algorithms optimize mission planning, navigation, and data analysis, reducing the need for extensive ground support and lowering operational costs. The involvement of private companies has been instrumental in driving technological advancements in space travel. Companies like SpaceX, Blue Origin, Rocket Lab, and others are competing to develop innovative solutions that reduce costs and increase efficiency. Public-private partnerships, such as NASA's Commercial Crew Program, leverage the expertise and resources of both sectors to achieve common goals. NASA's Commercial Crew Program contracts private companies to transport astronauts to the ISS. This partnership allows NASA to focus on its deep space exploration goals while fostering a competitive market that drives innovation. The successful collaboration between NASA and SpaceX has resulted in the Crew Dragon spacecraft, which has safely transported astronauts to and from the ISS, marking a new era in human spaceflight. The dream of affordable space travel is a global aspiration that transcends national boundaries and requires collective efforts. As space exploration becomes more accessible, collaboration between countries, organizations, and private entities is essential. International cooperation in space exploration is not a new concept. The International Space Station, ISS, stands as a testament to what can be achieved when nations work together towards a common goal. Launched in 1998, the ISS is a joint project involving NASA, Roscosmos, Russia, JAXA, Japan, ESA, Europe, and CSA, Canada. This orbiting laboratory has enabled countless scientific experiments, technological advancements, and international camaraderie. The ISS showcases the benefits of pooling resources and expertise. Each participating country contributes financially, technologically, and scientifically, reducing the burden on any single nation. This shared approach allows for more ambitious projects and paves the way for future cooperative endeavors, such as the Artemis program, which aims to return humans to the Moon and establish a sustainable presence there. Numerous collaborative missions and projects have demonstrated the value of international cooperation in reducing costs and enhancing the scope of space exploration. The ESA has been a leader in fostering international collaboration. Projects like the Mars Express mission, which involves contributions from multiple European countries, and the Bepi-Colombo mission to Mercury, a joint venture with JAXA, highlight the effectiveness of shared efforts. These collaborations not only spread the financial burden but also combine diverse expertise and technologies. The Lunar Gateway is another ambitious project that exemplifies international cooperation. Part of NASA's Artemis program, the Gateway will serve as a space station orbiting the Moon, providing support for long-term lunar missions and future deep space exploration. Partners in this project include ESA, JAXA, and CSA, each contributing modules, technology, and resources. By sharing the costs and responsibilities, the Lunar Gateway becomes more feasible and cost-effective. Collaboration is not limited to national space agencies. Private companies are increasingly playing a pivotal role in international space efforts. SpaceX, for instance, has partnered with NASA and other space agencies to provide launch services and crew transportation. These partnerships leverage the agility and innovation of private enterprises while benefiting from the resources and experience of government agencies. Emerging space nations, such as India and China, are becoming significant players in space exploration. Their contributions and collaborations offer new opportunities for reducing costs and expanding capabilities. The Indian Space Research Organisation, ISRO, is renowned for its cost-effective space missions. The Mars Orbiter mission, Mangalyaan, launched in 2013, cost only $74 million, a fraction of what other space agencies have spent on similar missions. ISRO's emphasis on frugality and innovation makes it an attractive partner for collaborative projects. Joint missions, such as the NASA ISRO Synthetic Aperture Radar (NISAR) satellite, leverage ISRO's cost-effective approach and NASA's technological prowess. The China National Space Administration (CNSA) has made significant strides in space exploration, including successful lunar missions and the construction of the Tiangong space station. While geopolitical considerations can complicate collaboration, scientific and technical partnerships with CNSA offer potential cost-sharing benefits. Joint projects, such as the China-Europe Double-Star mission studying Earth's magnetosphere, demonstrate the feasibility and advantages of international cooperation. Global organizations and consortia play a crucial role in facilitating international collaboration and reducing the costs of space travel. UNOOSA promotes international cooperation in the peaceful use and exploration of space. Through initiatives like the Space Law Treaty and the Outer Space Treaty, UNOOSA helps establish legal frameworks that encourage collaboration and resource sharing. These treaties ensure that space remains a domain for all humanity, fostering a cooperative environment. The IAF brings together space agencies, companies, and academic institutions from around the world. Its annual International Astronautical Congress, IAC, serves as a platform for sharing knowledge, discussing collaborative opportunities, and showcasing technological advancements. The IAF's efforts in fostering dialogue and cooperation contribute to reducing the overall costs of space missions. Public-private partnerships, PPPs, are becoming increasingly important in the pursuit of affordable space travel. These collaborations combine the strengths of government agencies and private companies, leading to cost-effective solutions and innovative technologies. NASA's commercial crew and cargo programs exemplify successful PPPs. By contracting private companies like SpaceX and Northrop Grumman to transport cargo and crew to the ISS, NASA reduces its operational costs and stimulates the commercial space sector. These partnerships have resulted in the development of the Dragon and Cygnus spacecraft, both of which play critical roles in maintaining the ISS. ESA's Advanced Research in Telecommunication Systems (ARTES) program supports public-private partnerships in the development of innovative satellite communication technologies. By co-funding projects with private companies, ESA accelerates the commercialization of new technologies, benefiting both the space industry and the broader economy. While international cooperation and collaborative efforts offer significant advantages, they also present challenges. Geopolitical tensions, differing priorities, and technological disparities can complicate collaborations. However, the benefits of shared resources, expertise, and costs far outweigh these challenges. The future of affordable space travel will depend on the continued commitment to international cooperation. As new players enter the space arena and technological advancements progress, the potential for collaborative missions will expand. The establishment of international space consortia, similar to the European Space Agency but on a global scale, could further streamline efforts and reduce costs. Ultimately, the dream of affordable space travel is a shared aspiration that can inspire a global community. By working together, nations can achieve more than they ever could alone. The spirit of cooperation not only drives technological progress but also fosters a sense of unity and shared purpose. As we look to the stars, let us remember that the journey is not just about reaching new frontiers but doing so together, as one global community. In the quest for affordable space travel, miniaturization and efficiency are critical factors that drive down costs and make space missions more accessible. By reducing the size and weight of spacecraft and utilizing innovative technologies, we can achieve significant cost savings while maintaining mission effectiveness. Miniaturization in space technology has been a game changer, allowing for the creation of smaller, lighter, and more cost-effective spacecraft. This trend began with the development of microelectronics and has since expanded to encompass various aspects of space missions. One of the most significant outcomes of miniaturization is the CubeSat. Introduced in the early 2000s by Stanford University and California Polytechnic State University, CubeSats are small satellites typically measuring 10 by 10 by 10 centimeters and weighing about 1.33 kilograms. These compact satellites have revolutionized space research and exploration by providing a low-cost platform for a wide range of missions. CubeSats offer several advantages that contribute to their cost-effectiveness. 1. Lower launch costs. Due to their small size and weight, CubeSats can be launched as secondary payloads on larger rockets, significantly reducing launch expenses. 2. Rapid development. The standardized design and availability of off-the-shelf components allow for quicker development and deployment compared to traditional satellites. 3. Educational opportunities. CubeSats provide an affordable entry point for educational institutions, enabling students and researchers to gain hands-on experience in satellite design, construction, and operation. CubeSats have been used for various scientific, commercial, and educational missions. Notable examples include NASA's MARCO, Mars Cube 1. These twin CubeSats accompanied the InSight mission to Mars, demonstrating the capability of small satellites to relay data from deep space. Planet Labs Flock, a constellation of Earth-observing CubeSats that provides high-resolution imagery for applications such as environmental monitoring, agriculture, and disaster response. Efficient propulsion systems are essential for reducing the cost of space travel. Traditional chemical rockets, while powerful, are not always the most economical choice, especially for long-duration missions. Advances in propulsion technology are paving the way for more cost-effective space travel. Ion propulsion is a highly efficient method of propelling spacecraft, particularly for long-duration missions. Unlike chemical rockets that rely on explosive reactions, ion thrusters generate thrust by ionizing a propellant, usually xenon, and accelerating the ions through an electric field. This process provides a continuous, gentle thrust that is highly efficient in terms of fuel consumption. The Dawn spacecraft, launched by NASA in 2007, utilized ion propulsion to visit the asteroid Vesta and the dwarf planet Ceres. The efficiency of ion propulsion allowed Dawn to travel between these distant targets with a minimal amount of propellant, demonstrating the potential for cost-effective deep space missions. Solar electric propulsion combines solar power with ion propulsion, further enhancing efficiency. By using solar panels to generate electricity for the ion thrusters, September systems can operate for extended periods, making them ideal for missions to distant destinations within the solar system. The use of lightweight materials and advanced manufacturing techniques plays a crucial role in reducing the cost of space travel. By minimizing the weight of spacecraft components, we can lower launch costs and improve overall mission efficiency. Carbon composites are lightweight, strong, and durable materials used in the construction of spacecraft. These materials reduce the weight of the spacecraft without compromising structural integrity, allowing for more cost-effective launches. Additive manufacturing, commonly known as 3D printing, has revolutionized the production of space components. This technique allows for the creation of complex parts with reduced material waste and lower production costs. SpaceX, for example, uses 3D printing to manufacture rocket engine components, significantly cutting down on manufacturing time and expenses. The concept of on-demand manufacturing in space is another exciting development. By using 3D printers aboard spacecraft or space stations, we can produce tools, spare parts, and even entire structures as needed, reducing the need for costly resupply missions. NASA's partnership with Made in Space has demonstrated the feasibility of this approach with the first 3D printer on the ISS. Efficient power systems are vital for reducing operational costs and ensuring the success of space missions. Advances in energy storage, generation, and management contribute to the overall efficiency of space travel. Solar power is a primary energy source for many spacecraft, particularly those operating within the inner solar system. Advances in solar panel technology have led to higher efficiency and lighter panels, providing more power for spacecraft systems while reducing weight and cost. Efficient energy storage systems, such as advanced batteries and supercapacitors, are essential for managing power needs during periods when solar energy is not available. Innovations in battery technology, including the use of lightweight materials and higher energy densities, contribute to the overall efficiency of space missions. Effective thermal management systems are crucial for maintaining the proper operating temperatures of spacecraft components. By using advanced materials and innovative designs, we can improve the efficiency of thermal control systems, reducing the energy required to maintain optimal conditions. Autonomous systems and artificial intelligence, AI, enhance the efficiency and safety of space missions. These technologies reduce the need for extensive ground support and enable spacecraft to perform complex tasks independently. Autonomous navigation systems allow spacecraft to navigate and perform maneuvers without direct human intervention. This capability is particularly valuable for missions to distant destinations where communication delays make real-time control impractical. AI algorithms can process and analyze vast amounts of data collected by spacecraft, identifying patterns and making decisions in real time. This capability reduces the need for extensive data transmission to Earth, saving both time and resources. Robotic systems, such as robotic arms and rovers, enhance the capabilities of space missions by performing tasks that would be difficult or dangerous for human astronauts. These systems improve efficiency and reduce the need for costly human intervention. The vision for the future of space travel involves not only reducing costs but also expanding the scope of human presence in space. This includes sustainable exploration of the Moon, Mars, and beyond, the establishment of space habitats, and the development of a thriving space economy. Returning to the Moon is a key goal for many space agencies and private companies. The Artemis program aims to establish a sustainable human presence on the Moon by the end of the decade. This involves building lunar bases, utilizing lunar resources, and developing technologies for long-term habitation. Mars has long been the focus of human exploration dreams. Missions such as NASA's Perseverance rover and SpaceX's Starship aim to pave the way for human exploration and eventual colonization of Mars. Establishing a permanent human presence on Mars will require advances in life support systems, in-situ resource utilization, ISRU, and efficient transportation methods. The construction of space habitats and stations, both in low Earth orbit, LEO, and beyond, is crucial for extended human presence in space. Concepts like the Lunar Gateway, orbital hotels, and space habitats designed for deep space missions will play a significant role in making space travel more sustainable and accessible. The development of a space economy involves leveraging the unique environment of space for commercial purposes. This includes satellite-based services, space tourism, asteroid mining, and manufacturing in microgravity. A robust space economy will drive further investments and innovations, making space travel more affordable in the long run. While the future holds immense potential, several challenges must be addressed to achieve the goal of affordable space travel. These challenges span technological, financial, regulatory, and environmental domains. Radiation protection. Protecting astronauts from harmful space radiation is a major concern for long-duration missions beyond Earth's magnetic shield. Advances in materials science and protective technologies are needed to mitigate these risks. Life support systems. Developing reliable and sustainable life support systems is essential for long-term space missions. This includes water recycling, air purification, and food production in space environments. Propulsion systems. While ion propulsion and solar electric propulsion have shown promise, further advancements are needed to develop more efficient and faster propulsion methods for interplanetary travel. Funding and investment. Space missions are expensive, and securing funding remains a significant challenge. Public-private partnerships and international collaborations will be crucial for sharing costs and pooling resources. Cost reduction strategies. Continuous efforts to streamline operations, improve manufacturing processes, and leverage economies of scale are necessary to further reduce the costs of space missions. Space debris. The proliferation of space debris poses a threat to space travel and satellite operations. International regulations and active debris removal strategies are needed to ensure the sustainability of space activities. Space law and governance. The legal framework governing space activities must evolve to address new challenges and opportunities. This includes issues related to property rights, resource utilization, and the management of space traffic. Environmental impact. The environmental impact of rocket launches and space activities on Earth's atmosphere and ecosystems must be carefully managed. Sustainable practices and technologies should be prioritized to minimize adverse effects. Planetary protection. Ensuring that space missions do not inadvertently contaminate other celestial bodies or bring harmful materials back to Earth is crucial for the preservation of extraterrestrial environments and Earth's biosphere. Addressing these challenges requires a multifaceted approach, combining technological innovation, international cooperation, and strategic investments. Breakthrough technologies. Investing in research and development of breakthrough technologies, such as nuclear propulsion, advanced materials, and autonomous systems, will drive down costs and improve mission efficiency. Public-private partnerships. Strengthening public-private partnerships can accelerate the development and deployment of new technologies. Collaborative initiatives, like NASA's Commercial Lunar Payload Services, CLPS, enable private companies to contribute to space exploration efforts. Global collaboration. Building on the successes of the ISS, international cooperation should be expanded to include emerging space nations and private entities. Collaborative missions and shared infrastructure will distribute costs and enhance capabilities. Unified regulations. Developing a unified regulatory framework that addresses the challenges of space debris, resource utilization, and space traffic management will ensure the sustainable growth of space activities. Incentivizing investment. Governments can incentivize investment in space ventures through grants, tax incentives, and supportive policies. Encouraging private investment will spur innovation and reduce financial barriers. Commercial opportunities. Expanding commercial opportunities in space, such as space tourism, satellite services, and asteroid mining, will create new revenue streams that can fund further exploration efforts. Inspiring the next generation. Investing in educational programs and outreach initiatives will inspire the next generation of scientists, engineers, and entrepreneurs. Promoting STEM education and providing hands-on experiences with space technology will cultivate a skilled workforce for the future. Public engagement. Engaging the public through media, social platforms, and community events will build support for space exploration and highlight its benefits for humanity. The journey to affordable space travel is an ongoing and collaborative effort. The advancements in miniaturization, efficiency, and international cooperation have brought us closer to this goal, but significant challenges remain. By fostering innovation, strengthening global partnerships, and addressing regulatory and environmental concerns, we can realize the dream of making space travel accessible and sustainable for all. As we look to the future, the potential for discovery, exploration, and economic growth in space is boundless. The dream of affordable space travel is not just about reaching new frontiers, it is about doing so in a way that benefits all of humanity. The path ahead will require dedication, collaboration, and a shared vision of a future where space is within reach for everyone.